which we can drop in the chat room, and you can find out about these seminars and others like it over the course of the semester. Next week, we will have Barbara Stallings from Brown University. She'll be discussing her new book, Dependency in the 21st Century, The Political Economy of China-Latin America Relations. These seminars are wide-ranging. Some weeks they're folks just starting a research project and outlining what their research design is and how they're going to approach it, and asking for feedback at that level. And in other cases, folks will be talking about a just published article, or in Barbara Stallings' case next week, a brand new book on the subject. So the spirit of these, especially when they were just rolling up our sleeves in our seminar room, was just to give folks constructive feedback and to have conversations. We're going to scale that up on a global level, but just to let you know now, that's sort of how we approach these. The speaker speaks for about a half hour, and then we have questions and answers from all of you out there. And we ask you to put those into the Q&A function. If you look at the bottom of your Zoom screen, you will see a Q&A function where you can ask questions throughout, and I will field some of them and ask the speakers to answer specific ones, as many as I can during the time that we have after they're done speaking. So today's topic is environmental sustainability and China's hydropower development in Southeast Asia. And we're excited to kick it off with our own Cecilia Springer. Cecilia Springer actually joined the GDP Center's Global China Initiative back in August. Her interdisciplinary research focuses on the environmental impacts of China's overseas investment, policymaking processes within China, and industrial decarbonization. Previously, she was a postdoctoral fellow at the Harvard Kennedy School, and she got her master's degree and PhD from Energy and Resources Group at the University of California, Berkeley, and from environmental science from Brown University. She's going to be joined by Dinah. She's a senior software engineer at GitHub, moonlighting as a research assistant on China's extended environmental footprint. She's interested in Chinese climate policy, particularly in the continued dominance of coal in Chinese power generation. She's got a bachelor's degree in software engineering from the University of Waterloo. So without further ado, please let me hand it over to Cecilia Springer and Dinah. Those folks will share their findings and their research with you for the next half hour, and then we can have a global conversation about it. Cecilia.
Thanks, Kevin. I just wanted to ask the host to enable screen sharing. It looks like I cannot share my screen right now.
Yep, you can now.
Thank you. And can everybody see my screen?
We can.
Okay, hold on. I'm looking for presenter view. I think I clicked the wrong button. Thank you everybody for being patient with me. This is my first Zoom webinar. Okay, so can everybody see my screen and just the PowerPoint and not my personal notes?
All set.
Great, thanks so much. Okay, everyone, thanks for being here today. I'm really excited to kick off the Global China Research Colloquium. And I'll be talking about environmental sustainability and China's hydropower development in the greater Mekong region. And just to outline my talk, first I'll tell you a bit about why I'm interested in hydropower specifically, as well as why I'm focusing on the Mekong region. And despite what I would call a rather broad title for my talk, I'm then going to spend the rest of the presentation really digging in to the sort of the methods and the data to do this research, which is still in the early stages. So I'll be very excited to hear your feedback. But I do think it's really important to lay out some of the methodological considerations, because this is the scope of the project is sort of in a region where there isn't always great data. And so I want to think carefully about how to evaluate the kinds of questions I'm looking at. And then I'll share a little bit about the next steps of the project. As I said, it's still early stages, but I hope to paint a picture of where we're going. So first, why am I studying hydropower? So a lot of my previous research has actually been on coal-fired power plants, and energy and emissions intensive industry, which I think of as sort of the sticky infrastructure that is really difficult to decarbonize, and that lasts for a really long time. And hydropower is also a massive centralized technology. And I think it's, you know, just looking here at this picture of the Three Gorges Dam, it's really emblematic of our relationship with the natural world and our control of natural resources. Now, that being said, in contrast to the types of energy and industry that I've studied previously, hydropower is typically billed as a clean energy resource in that it's low or even sometimes called zero emissions in terms of the greenhouse gases that it emits during its lifetime. However, hydropower is not necessarily green, clean but not green, because of the massive local environmental impacts that it can have. Just in this picture, you can see the reservoir behind the dam, where obviously there was you know, huge amounts of area, you know, for both agricultural purposes as well as where people live, forests that had to be flooded, changing the ecology of the river landscape forever. So, you know, hydropower may not actually be zero emissions. I would be remiss not to mention that, you know, it's frequently assumed as such in energy modeling and energy planning, but in fact there can be some emissions due to buildup of organic material behind the dam that degrades over time. So, you know, hydropower is sort of in this paradoxical positioning where the energy and climate perspective of it as a clean energy source is not always in dialogue with the sort of local environmental perspectives that focus on all the changes that are happening along the river itself, as opposed to at the global level. I'm also really interested in hydropower because of its fascinating history in China. And that's something I hope to delve into as I sort of get deeper into this research. But, you know, just anecdotally, there's sort of a disproportionate number of China's leaders who have been trained in hydropower engineering. China has relied heavily on hydropower ever since the early days of its industrialization. And now is a global player, of course, in bringing hydropower around the world. So I'll talk about that more in a second. And why am I interested in the greater Mekong subregion? Shown here, it includes Myanmar, Laos, Thailand, Cambodia, Vietnam, and China, specifically Yunnan province. So, you know, this area has been a historic site of, you know, investment, exchange, migration between China and these parts of Southeast Asia. It's an extremely diverse region, obviously home to the Mekong River, and has been through, you know, a lot of turmoil in the 20th and 21st centuries, much of it sort of along the river, the shifting borders that the river now defines. And, you know, given all its diversity, it might still seem a bit too ambitious to even focus on this region as a whole. But my previous research was trying to look at thousands of coal plants across all of Asia. I then tried to narrow down to Southeast Asia, but even that is, of course, an incredibly diverse region. And so I felt that focusing on the greater Mekong might be somewhat more achievable for a semi-large scale quantitative analysis, in that it could be perceived as a single governance region. You know, there are sort of mechanisms for cooperation among these countries, like the Mekong River Commission, or even bigger groups like ASEAN. So I hope that, you know, I can at least start to get a feel of, you know, the findings within this context by focusing on a specific region, and one that is absolutely at the frontier with China and its overseas investment, as well as being, you know, physically connected to China via the Mekong and its tributaries. So first, a word about hydropower and energy in this Mekong region. So this slide shows the sort of energy or the electricity generation by source for the 5 countries, not including China, in the Mekong region. And you can see that some countries are more dependent on hydropower than others for their electricity generation. And it's important to note that looking forward, this is a region that is portrayed as having a huge growth in demand for electricity as their economies develop, industries develop, and so on. This is of course pre-COVID. And some countries will be meeting that future demand with hydropower more so than other countries, sort of depending on their resource constraints. It's also important to note that the energy systems of these countries are also very interlinked, not just in terms of trade of fuels, but also there are lots of imports and exports of electricity across borders, which is really emblematic in Laos's branding of itself as the battery of Asia, a strategy to sort of build out electricity generation there and export it to neighboring countries. And here I've just overlaid the total electricity generation in 2018 for these countries. So you can see, of course, that some are bigger than others. And these numbers also sort of belie the fact that there's a big difference in electricity access across these countries. So Vietnam and Thailand have near universal access to electricity, while Cambodia is just above 90% of the population that has access to electricity, while Myanmar actually has the lowest rate of electricity access in the region, with just 2/3 of people who have access. So these are also important things to note when thinking about future needs for electricity in each of these countries and how they're going to meet those needs. And so now I want to talk about China's role in the Mekong. This is the Global China Research Colloquium. I think probably most of the audience here has some familiarity with the Belt and Road Initiative. And as I said earlier, this is very much the frontier of that investment, but that long predates the announcement of the Belt and Road Initiative in 2013. So the greater Mekong region has been, a historical site of investment exchange. But in recent years, and apologies for the noise, this happens to be a loud day on my street, there has been this trend highlighted by the Stimson Center in an excellent report earlier this year of upstream water impoundment in China having very severe consequences for water management in the lower Mekong region, which is, at least last year, suffering from serious drought. So you can see in this image that the expected river level in blue was actually, the actual river level in orange was much lower, and this was especially so in 2019. So at the same time that China is sort of having an impact, this isn't entirely driven by China, there's also weather patterns and other considerations. But China is also investing downstream in the Mekong region. Most of the recent hydropower developments in the Mekong do have some form of Chinese involvement. So there's this kind of dual trend of China damming upstream and investing downstream. I should also note that hydropower is second only to coal in terms of China's overseas investment in electric power. I got that data, of course, making a plug for our own databases here at the EU, the CGEF. Historically, China has been involved in more than a quarter of hydro projects in mainland Southeast Asia. But if you look at recent years, that share is a lot higher. And this trend of increasing Chinese involvement, both upstream and downstream, has not come without, of course, a local response. It's important to note that there's a huge diversity of actors, sort of facilitating as well as resisting these trends. And there's a long history of local activism against a lot of dam development. So I don't want to gloss over that. China is very much seen as a dual source of problems for a lot of these countries, both from management of water resources across the border to taking over of domestic infrastructure. So with all of that background in mind, my goal is to begin to speak to a sort of systematic understanding of the uniqueness of Chinese investment, given global concern over the Belt and Road initiatives, as well as local sort of concern within these countries about what China is doing. And so my prior research looked at this question for coal plants, as I mentioned, but now I want to ask, are there systematic differences in the environmental performance of Chinese and non-Chinese hydropower projects in the greater Mekong region? And sort of second to that, I also want to explore how narratives of sustainability differ between these Chinese and non-Chinese hydropower projects in the Mekong. So as I mentioned earlier, hydropower may be portrayed as clean in terms of emissions, as well as being, a major driver of local environmental impact. So how do different actors sort of narrate the sustainability of their projects? And this question, I'll just say now, is going to be a bit delayed or changed in its scope. I had originally hoped to go do extensive field work, but obviously due to the pandemic, that's not possible currently. So I'm rethinking that approach. But I do think, it's a really important comparative question of thinking about how sort of traditional Western developers that had been active in the Mekong region for hydropower, what kind of environmental narratives that they told, how has that changed over time, and how does that compare to how Chinese developers are sort of portraying what they do? But let's table the second question for now and focus on the first, which will be a little bit more of a quantitative analysis that I can do from home. And so again, to expand on how I'm thinking about doing this research, I really think it's important to have a comparative approach for looking at the effects of Chinese investments. I think a lot of times in the media or sort of broader discourse, there's this assumption that the existence of a infrastructure project like a coal plant or a hydropower plant equals XYZ amount of lifetime environmental impact. And that's definitely true in a sense, and it's important to estimate those impacts, but it's also important to think about what might have been built had that plant not been built. Who else would have built it, and how would they have operated it? And also, if said plant will be handed over to another manager, how might that manager operate it? So there's no way to experimentally assess these counterfactuals. And so I kind of, in my prior research, came up with this framework of using a regression approach to try and isolate the environmental performance, the effect on environmental performance of having Chinese involvement for a given plant. And so I was looking at the CO2 emissions intensity of overseas coal plants and comparing the Chinese ones to the non-Chinese ones. I think that this framework can be applied to looking at hydropower plants. I do hope that this time around I can sort of add more detail, given that it's sort of a smaller scope, as I mentioned, regionally. And I also think that there now is emerging better data to answer this question. So instead of having a binary of Chinese involvement or not Chinese involvement, I think that I can pull in detailed financial data and better characterize the different kinds of actors that are involved. So happy to talk more about this approach methodologically if anybody wants to in the discussion. But the first big question, of course, is defining what makes a project, or a hydropower plant in this case, Chinese. And I think that, we're still, as a research community, sort of developing this vocabulary and how to think about this. But so, what I had done previously is identify the country of origin for several different kinds of companies that are involved in managing, building, or operating the plant. And I think the additional data that I mentioned that is now becoming available looks at if Chinese institutions are actually financing a given project. So are Chinese policy banks involved, like the China Development Bank or China Exim Bank? And, if possible, finding data on if Chinese commercial banks are involved in financing these projects. In addition, there could also be foreign direct investment from Chinese companies. And all of these arrangements could be in tandem or separately. There's sort of a very complex overlapping Venn diagram of how these actors could be involved. But I do think that having a sort of more fine-grained characterization of this involvement can help us better understand what makes a project Chinese, which in turn can help us think about how does a plant having Chinese involvement mediate its environmental performance. And so, you know, that's something that, again, needs to be answered with sort of field work or case study approaches, but that can be sort of indicated by this first round of quantitative analysis. And so, you know, we've started the process, Dinah and I, of merging and comparing the available data sets. And so far we're using 3 that hopefully some of you all are familiar with. We have the Platts World Electric Power Plants database, which is regularly updated, compiled by an industry group. I would say that, relatively speaking, it's well formatted and high accuracy, but it's tends to be a little bit behind in terms of being updated what sort of groups that are more actively tracking specific sectors or regions may know. For example, the Stimson Center's Mekong Infrastructure Tracker, which is obviously devoted just to the region, and is sort of, it was launched earlier this year, meant to be, I think, eventually a really important tool for crowdsourcing and sharing information. It does have more varied formatting than Platts, for example, and is mostly built on secondary sources. And then we have our Boston University here, the China Global Power Database. So keep an eye out for this. It will be launched in late October, October 27th, I believe, to the public. And so we're using this data, which has a lot of financial detail, which, as I mentioned, is really important to not just have the technology detail that's in Platts, but also detail on the financial actors that are involved. So this database from BU has very high data integrity, but it's relatively small because it only covers Chinese projects. So from here, I'll turn it over to Dinah to talk a little bit more about how we merged and compared these data sets.
Great, thank you. So I'm going to take us through how we went about merging some surface level stats on the merged data set, some early results characterizing agreement, and then lessons learned from deep diving into the data sources. But before we get into the merge algorithm itself, I wanted to give a sneak peek of the data that we're working with. So the first thing that I did upon receiving the 3 databases was look for a plant that was tracked by each of the sources, and that's what we see here. The top box is Stimson, the middle is Platts, and the bottom is BU. So the first thing that stands out is that Platts has 3 rows for this one plant, whereas the other 2 sources have 1. And that's because Platts actually tracks plants by unit, where the other sources track by plant. So that's something we'll need to take into account. Another thing that jumps out at us is that there's no clear shared identifier, which is going to make joining these databases a little bit difficult. The closest thing to that is project name or plant name. But even when we look at that field, we notice that the name formatting can be quite different with different case sensitivity, different spaces and punctuation used. So we'll need to account for that as well. Next slide, please. So following that theme of name formatting being problematic, here we see that there's actually variation in formatting within the Stimson data set itself. This first row shows that there is an alternate name provided in parentheses, and in this case, it's probably an alternate romanization. And then the second row shows the case where there is a suffix that's been added, and this is the word dam. Sometimes we've seen the word hydropower plant or hydro project added, and that's going to be problematic as we try to find matches between data sets because other sources will just have the project name and not those suffixes. Next slide. So taking those considerations into account, we built this merging method. The first thing that we do is pre-process the Platts data by aggregating on the plant level so that we're not looking at individual units and we can make comparisons with the other sources. The rest of the steps here happen in a Ruby script that takes in 3 CSV files, the pre-processed Platts database, the BU database, and the Stimson database. And we iterate over these plant names with each of 4 matching strategies. The first strategy is a manual override. So this is a hard-coded mapping at the top of the Ruby script, and it'll be plants that we've noticed from exploring the data ourselves that match across sources, but for whatever reason is a little difficult to identify programmatically. We'll add that to the manual overrides list, and we want to make sure we respect that first. The second strategy is a naive string match, where we take the project name and we remove all of the spaces and punctuation and compare them, ignoring case sensitivity. The third is ignoring suffixes, and this is targeting the Stimson dataset, where if we find the word dam or we find the word hydro, we'll ignore that word and everything following it, and then compare using the same naive string match where we remove spaces and punctuation. And then the fourth strategy is also targeting Stimson, and it's trying to use the alternate name where we use the name in parentheses as opposed to the first name given. After these 4 matching strategies, which are all targeting the plant name, we try to group phases where other sources have them grouped. And what this means is if, for example, Stimson lists a plant's 3 phases as separate plants, but the BU dataset has these 3 phases grouped into one large project, it's a little difficult for us to compare that data programmatically, even though we know that they're referring to the same physical plant. So in that case, we want to make sure that we group the 3 phases in the Stimson dataset in this contrived example, or more broadly, we want to make sure that we're grouping phases where one of the sources have them grouped. So we take the mapping that's built from all of this, the plant name mapping, and then we build a merged data set from that. And these are kind of some of the characteristics of the merged data set that we've built. So there's 1,249 plants in total, and 300 of those have data from more than one source. That's about 25%, so there's still a lot of room for improvement on our matching strategy and the script itself. We hypothesize that a source of noise in the data is microhydro, and microhydro is defined by China as a hydropower plant with a capacity of less than 50 megawatts. So these smaller mom and pop hydro, you could consider them, are probably going to have a lot less press about them, and they often fly under the radar of some tracking databases. So we tried removing them, and that brought the total count down to 338, 144 of which have data from more than one source. So we already see a fairly significant increase in the percentage of plants with data from multiple sources when we exclude microhydro. And then the bottom row shows a very rough floor estimate of the number of plants with Chinese involvement. So as Cecilia already mentioned, defining Chinese involvement and then trying to find that is a very difficult task in and of itself. This is a very rough estimate where we count a plant as having Chinese involvement if, 1, it shows up in the BU dataset, because we know that the BU dataset only tracks Chinese plants. If 2, in the Stimson dataset, it has a developer country that's listed as China, or the developer countries list includes China. The hardest case is the third case, where this plant only has data from Platts and not from the other 2 sources. And that's because Platts doesn't give us information about the country of origin of the owning country, or sorry, of the owning company of the plant. So to get around this, we have a hard-coded list of about 10 companies that we know to be Chinese. And if we see in the Platts data that the owning company is one of these companies, we count the plant as Chinese. So with only 10 companies, that's certainly a severe underestimate, which probably explains why these numbers are fairly low. But that's kind of a first pass. Next slide. So the next thing that we want to look at after merging this data is understanding to what extent do the sources agree with one another, and also to what extent has the merging of data been successful. So the field that we decided to look at was capacity. This is one of the few shared attributes across all 3 sources, and it's also numeric, which makes it a little easier to work with. So we calculated the standard deviation across the 3 capacity values from the 3 sources. And what we see on the left is the stats for the entire data set, and then on the right is excluding microhydro. So for the entire data set, we see there's about 300 observations with more than one capacity value. 175 of those have a standard deviation of 0, meaning that the data matches completely. And then the remaining 123 are shown in the density plot on the left. And those same stats are shown for the data set excluding microhydro on the right. So these density plots tell us that even one standard deviation is non-zero, which is to say that the values don't agree perfectly. The standard deviation is fairly low with the exception of a couple of outliers. So that's a really good sign. It means that for the most part, the capacity values do agree with one another. And we've probably done a decent job at mapping plants to one another across sources. Next, we looked at a slightly more interesting field, and that's the lender field. This is only available in the Stimson MBU dataset, and it's also a little harder to work with because it's not numeric, it's a string. We had to do a little bit of data mapping because there are different naming conventions between the two datasets, Stimson and BU, but we found that in the small number of cases where both sources had a lender specified, the data actually did agree 100%. So that's a really good sign, even though the count is only 17. That really lends to the accuracy of both of these data sets and ideally the accuracy of the merging algorithm as well. So we wanted to share some of the lessons learned from doing this deep dive into the data so far. The first that I've really been going on and on about is that naming varies a lot between sources, and that's expected. A lot of the time, these plant names aren't necessarily in English, so they need to be Romanized or translated somehow. And it's very hard to get everyone working in the field to follow the same naming convention, excuse me. So this is not likely to change anytime soon. Given that, it's really important to have a consistent unit ID across all data sources to make the merging of data a lot easier. If there had been a consistent unit ID, everything that I've talked about so far would have been pretty trivial to do. Third, that Cecilia has already mentioned, is it would be really valuable to establish a shared vocabulary. What is the difference between a parent company, a developer company, and a sponsor company? What's the difference between an investor, a lender, and a financer? These are some of the questions that we started to ask as we were looking at data across sources. And we think that this would be valuable beyond data merging, but for the field at large to establish that vocabulary so it's very clear what I'm talking about when I talk about a sponsoring company. We saw as a group that some data sources track information at the unit level versus the plant level, and that's fine. We just need to make sure that we practice caution when we're aggregating data, that we're not losing important information, and that we're properly aggregating fields like summing all of the capacities of subunits for the capacity of the plant. From looking at hydropower plant data as well as other power plants, we know that there are pretty different fields of interest for different technologies. Of course, it's valuable to have a global power plant database to understand global energy mix and the geographic spread of technologies. And there are certainly lots of shared fields of interest, especially with respect to project financing. But when we want to delve into the details of how the technology performs, a general database may be too rigid to track some of those finer details. So that's where we would look to something like a hydro database. And as long as there's a consistent unit ID, it's very easy to join across those. So next steps with respect to data, the first thing is adding the World Resources Institute's Global Power Plant database to the mix. That's another great source for hydropower plant data. And the second is something that we can do with our existing data, which is grouping all phases. And this is a little different than the phase grouping I previously mentioned. What we've noticed by looking at the data is that in some cases, phases of a project are built in the same year with the same engineering company and the same lender. And that's what we see in the bottom 3 rows here. So in that case, it's pretty safe for us to consider these 3 phases as part of a larger project. But in other cases, phases are true expansion projects with a different year built, a different engineering company, and very different financing structure. And that's what we see in the top 3 rows here. The first phase is built in 1968 and has actually already been retired. The second phase was built in 2002 and the third in 2013. And we see that the owning company is different for each phase. So in this case, we definitely would not want to group these projects together. We'd be losing a lot of really valuable information and probably not characterizing the data accurately. And with that, I'll hand it back to Cecilia.
Great, thank you. And so, as we sort of work through the data, we're also continuing to look forward to also incorporating environmental metrics, which is of course the entire outcome variable that is being evaluated for this project. And so this is a rather complex task, and I do welcome, thoughts from the audience, because there are many, many different ways to evaluate the environmental impacts of hydropower plants. And I've listed a few here, all of which have, again, very different data availability and format. And so, I just wanted to mention that, looking at a sort of naive comparison of the averages for Chinese and non-Chinese plants as we've built out the data so far, we can already see that the Chinese plants are newer. So their average year of building is 2016, while other plants their average year is 2007. And as well as the size, a Chinese plant's average capacity is 530 megawatts, while the average size of non-Chinese hydropower plants in this region is about 260 megawatts. So the whole point of, sort of doing a regression approach is so that we can look at these environmental metrics while controlling for factors like size and age of the plant. So because obviously, a bigger plant is going to have a bigger environmental impact. So how do we really isolate what's going on with a plant that has Chinese management or finance versus one that does not? So looking forward, merging in environmental metrics is obviously going to be, the sort of critical next step. So I welcome thoughts from the audience on metrics of interest. Similarly, I think it's really important to look at social metrics of some kind. Obviously, displacement, resettlement are a huge part of what happens when a large reservoir is built. There have been a lot of instances of local conflict. And then I also wanted to highlight, as I mentioned earlier, for a lot of these hydropower plants, the electricity is not being used on the local grid, but rather exported far away. And so these are sort of some metrics that I'm starting to think about. Again, these can be really difficult to assess given data availability, but it is a goal, an eventual goal for the project. And so I'll just leave everybody with a couple of thoughts again about future directions. As Dinah mentioned, we're still thinking about how to handle small and micro hydro, because mechanistically these could have very different routes of environmental impact than the mega plants, of course, as well as sort of different modes of interaction between, for example, Chinese actors that may be involved. And I also, as I mentioned, given that fieldwork is not currently possible, I'm thinking about doing a case study or two. So again, this is to dive into, understanding how the actors are involved, how they mediate environmental performance, and how they also narrate their own environmental performance. So I'd welcome, again, thoughts on places to focus if anybody, has some ideas. I look forward to the discussion. Our discussion can be about the nitty-gritty of the data, which I think is really important for our research community to be discussing so that we can all work together, or it could be really big picture about BRI and Southeast Asia and topics like that. So with that, I'll just thank everybody who's listening and watching, and I look forward to the Q&A.
Thanks so much, both of you folks. Great presentation. As you folks in the audience can see, some of these presentations are in their early stage, and Cecilia and Dinah would love some early feedback. I should note that today's the presentations have been are being recorded, and please add questions that you have in the Q&A, and please also introduce yourself inside. Since there's so many folks, it's harder to just literally go around the room and let folks jump in. So when you have a question in the chat, please introduce yourself. So I'm going to start with and for both of the presenters, I think what I'll do is I'll read you 3 or 4 of them and let you answer, and then when you're done, we'll go back until we run out of time. Well, I'm going to start with the home team here. We've got a cluster of questions from noted biologist Les Kaufman, who's here at Boston University, and also has done a lot of work on Chinese hydropower in the Mekong. Let me see if I can summarize all of these quickly. So one of them is, in distinguishing between Chinese and non-Chinese hydropower plants, how do you account for the Chinese-funded projects sheltered by non-Chinese fronts from Southeast Asian countries? Another one that he asks is, has the overall scheme for hydropower development in the Mekong Basin taken climate change itself into effect? Is there a management plan to utilize the dam system to offset the impacts of regional drought? Because if so, that doesn't appear to be happening. Also, is any planned offset directed only towards sustaining competing water uses by people immediately, or does it include the need for freshwater flow to sustain the aquatic ecosystem, its ecosystem services, and the maintenance of biodiversity? We also have a question from Divya Narain. Divya is from the University of Queensland. She actually just published a noted article in Nature Sustainability on the BRI and biodiversity. Her question is, do you consider plants that are only built by Chinese contractors but not financed by China? To what extent can contractors influence environmental performance in these plants? And let me ask one more from Zelda Liang. Doesn't say Zelda's affiliation, but thanks for your question, Zelda. Zelda asks, very interesting. Will you compare the performance of projects with different involvement of Chinese actors and examine how much say Chinese actors have on the project design in each kind of involvement? And what are the sources of the BU database? I can answer that question. We've built a database called China's Global Power, which looks at Chinese involvements in electric power across the world. It's based on two articles, one in Energy Policy that came out earlier this year, and one that comes out on October 23rd in One Earth. And as Cecilia mentioned, we'll be releasing that an interactive data set where you can look at different power plants around the world and look at their lifetime emissions. Stay tuned for that in late October, early November. So let me hand it over to our two speakers to handle those. And folks, if you have other ones, put them in the Q&A and introduce yourself so we can have a global conversation.
Great, thank you everybody for the questions. I'll start with the question from Les. So first, how to distinguish the sort of hidden Chinese companies or ones that might be, for example, a joint venture with less than majority stake in a company that would probably have, for example, a Vietnamese name. That can be tricky. I have found, looking through the data, that joint ventures can often be identified. You know, it was a lot of work, but I actually went through by hand in my previous research and looked up the origins of every single company, and you know, whether it was a sort of Chinese joint venture with who had what stake in each. So I'm hoping that with this somewhat smaller data set that we'll be able to capture that detail. You know, if it is something truly hidden and nefarious, I don't know how we would capture that, but again, this is where case studies could potentially be illuminating about some of the things that go on in the different arrangements with you know, multi-country actors. To your question about sort of the management, you know, climate planning in the Mekong for, you know, understanding that the impacts of climate change are going to have a lot of ramifications for not only hydropower, electricity generation, but also water management. You know, I'm not very familiar with climate planning in the region. I know that, you know, some of my colleagues back at Berkeley have been involved in these kinds of discussions. And I do think it's something that's incredibly important to consider, because a lot of the energy planning discussion is looking at the year 2040 or 2050 and may not necessarily be also incorporating the climate impacts that we know we'll start to see on that same timeline. So for Divya's question, which is around if we're able to distinguish projects that might not have any Chinese finance, but that have the involvement of Chinese EPC contractors. So these are the companies that may be designing or building, and in some cases operating the plants. Yes, Platts does allow, the Platts data set does allow for distinguishing that. And it is very important because, and I think I saw another question about this, that does, I believe, at least indicated by my prior research, to some extent mediate environmental performance, because these companies are sort of designing the plant, choosing different technologies for it. And, you know, at least in the case of coal plants, for example, that could have a major impact on efficiencies and emissions intensity, things like that. And I hope to think about how that will work for hydropower for this project. And then lastly, Zelda asked, will we compare the performance of projects with different involvement of Chinese actors and examine how much those Chinese actors, their impact on the project design and each kind of involvement? Yeah, definitely. I think you've totally captured, you know, one of the more fine-grained aspects of what we hope to do with the research going forward. That's sort of why we're doing all of this arduous data merging and assembly, which is, you know, I think a lot of people on this call have probably been through a similar process. So yeah, that's definitely what we aim to do.
Thanks so much. We've got another round. We have a question here from Juliette Liu. She's a postdoctoral researcher for the Atkinson Center for Sustainability at Cornell University. And she asks, China often says it defers to host country environmental policies. Will you control for host country policy contexts? Jerry Harris asks, Jerry Harris is a national secretary of the Global Studies Association of North America. And Jerry asks, do transnational investors have any effect on sustainable governance of these projects? And Aram Ashraf, I have your affiliation, Aram, but I don't see a question by you. Am I missing something there? Do I not see that? And another one by Divya Narain, while I'm waiting for that, it says, do you make a distinction between BRI and non-BRI projects in this work? Why don't you take those, and if Aram types his in, I'll make sure to get him in the next one.
Yeah, so thanks, Julia, for your question. You know, I hadn't, at least in my previous research design, looking at coal plants specifically controlled for example, the presence of more or less stringent environmental policies in the host country. But what I did was look at a sort of country fixed effects approach in the regression, which is meant to control for sort of country level variation that might explain away some of the impacts of, you know, whether or not a company or involvement is Chinese or not Chinese. So hopefully that would sort of capture some of that. But you're definitely right that, you know, China's sort of main line that it repeats over and over is that, you know, rather than setting their own environmental standards for overseas projects, they follow the host country environmental policies. So of course, you know, every projects by different country are probably going to have some kind of systematic variation due to the host country's environmental standards. So hopefully our, you know, our research design will control for that. To Jerry's question about if transnational investors have effect on sustainable governance of the projects, I think that goes back to kind of what we were just talking about, wherein China tends to defer to what the host countries are doing. But, you know, if you're talking about transnational investors from other countries besides China, perhaps they could. I mean, I think there's a lot of dialogue, and I think you'll hear this in future colloquiums in this series about environmental standards and environmental governance of different organizations, multilateral development banks, for example, and other investors that do have very strict standards, and how that plays out for the projects on the ground. I think do I see that Dinah wants to chime in on this question?
Sorry, I'm just keeping the Q&A up to date with what we've already answered and what we haven't. I think that was a great response.
Oh, okay, sorry. And then the final question, sorry, I'm actually not seeing it anymore. So yeah, you might have to remind me, Kevin.
It was, do we make a distinction between BRI and non-BRI projects?
Oh, I see, thank you. Yes, no, I don't. And that's sort of on purpose, because as I mentioned, you know, this is sort of a continuous flow of investment both before and after BRI. I do think that's a really interesting question. Did BRI announcement or sort of implementation change, for example, how projects were managed environmentally? So I do think that's a really interesting question. Something that we could explore with like some kind of time variable or something like that. So I'll definitely keep that in mind as we think about that, especially now that discussions on a green Belt and Road Initiative and this sort of green BRI slogan that's emerging, that could definitely change, you know, how China engages with its overseas projects.
Great. It looks like we have one last round of questions here. We now have Aram Ashraf. He's an independent researcher from Wallasey, and he's interested in CPEC projects, which include hydropower. And he's interested in how you define ownership when it's shared between states and between state and private companies. Then we have a question from one of our Global China Fellows who'll be presenting later on this semester, Xia Li. Her question is, how do you predict the environmental impacts of hydro projects given Chinese projects are built in 2017? For coal and gas projects, we probably can calculate the emissions and predict, but I would imagine it might be much more difficult for hydro projects. How will you engage with that? And I thought we had one from Meyer Elcon, but we're having trouble picking that one up. So why don't you, Mayor, could you put your question in the panelist chat? Looks like we're having trouble on the Q&A end with you. And I'll add that one to the mix. Mayor can have the last question before we close out after you answer these two.
Great. Yeah, thank you. So so to the question about, you know, defining ownership when it's shared between state and private companies, I'm not sure exactly what you're referring to, but I might speculate that you're talking about how in China there can be a lot of differences in terms of sort of motivations, incentives and practices on the part of state-owned companies versus private companies. And so, you know, we haven't been going that into detail about the nature of each company beyond, for example, its country of origin. So we may see that Sinohydro is involved. We know that that's a state-owned company, but we're not necessarily coding for that. I think, especially when it comes to hydropower, given the scale of these projects, as well as I mentioned, sort of their, you know, history in China of very much being a part of state-led development, almost all of them are going to be state-owned enterprises that are, you know, involved with hydropower abroad. That's very different for renewable energy like wind and solar, where there are a lot more private developers. And I think that the sort of differences between state-owned enterprises and private enterprises is really important to investigate going forward, especially for people who are interested in you know, encouraging China to invest more in wind and solar versus traditional sources of energy like coal and hydro. But it hasn't been something that we're necessarily distinguishing for our quantitative analysis, but definitely would be a really important consideration in case studies, is to look exactly at who these actors are, you know, and they're state-owned, but, you know, which state-owned company are they, that kind of thing. So for Xia's question, yeah, I think, you know, so this is a question about what to do about, you know, the fact that a lot of these Chinese hydropower plants are so new that their, for example, lifetime environmental impact very much has yet to be understood. So I think this gets back to, you know, first selecting the right data. So I think, you know, eventually we may want to focus only on plants that are already in operation and are thus enacting environmental impact. Now, that's not necessarily true. Of course, once you start building a hydropower plant, there are going to be impacts. Similarly, there's, you know, anecdotally, this phenomenon of plants being built and not, so to speak, plugged in. And so, you know, if you've built a huge dam, and it may not be generating electricity, but it's certainly generating impacts of some kind. And that problem could continue to get more severe going forward, you know, as, you know, the economic effects of the pandemic affect electricity demand in the region. So I think this is a careful consideration that we need to think about when we're selecting our environmental metrics. Are these environmental metrics that are going to be time dependent and that don't match the data that we have for, which is sort of a snapshot of the present day? It would be great if someday there were panel data, but that certainly doesn't exist right now for this sort of technology and finance characteristics. There might be panel data for environmental impact, but yeah, that's a great question, Shad. I hope we can continue talking about it. So yeah, I'll pause there.
Thanks. It looks like we have one or two more questions. Yan Wang, if you could put yours. Okay, we have yours now too. So here's ones from Mir Alkon, who is a postdoctoral fellow at Harvard University and a postdoc in our Global China Fellows program. His note is: the contradiction between the downstream impacts of projects within China and the success of China's investments in the Mekong region is large. Do you see any evidence of efforts to coordinate state and commercial actors to avoid these contradictions? Then he says, relatedly, it seems important to include Chinese hydropower within China in the assessment of the environmental impacts, since most effects will occur at the basin level. Lastly, he says, a more data-focused thought: can you quantify uncertainty in the merged data to assess the likelihood that two observations that do not merge but actually represent one underlying plant? Those are questions from Dr. Alkon. And we have one from Yan Wang, a new senior non-resident fellow here at the Global China Initiative. She says, I would be interested to know the country's existing and alternative power sources, whether these hydropower stations are addressing the bottlenecks of the economic bottlenecks of the country. So that's our last round of questions. So why don't you folks take those questions and make any closing statements that you'd like. Then I'll just thank everyone for coming and give them heads up about a couple more events that are coming up at the GDP Center. Take it away, folks.
Great. You know, I'm really not surprised that Mir, who's a political scientist, would ask about this sort of big contradictory question that I raised in the introduction of the talk. I definitely agree that this is this kind of paradox where China is, you know, what it's doing upstream with parts of the mainstream Mekong in its own territory are very much affecting its potential investments downstream. I agree that this is a paradox. I thought about that in the framing of this talk. And it's not something that, you know, is being evaluated in the research design of this project. But I haven't seen a lot of discussion about it. And I think it could be a really important question going forward. And I think it really speaks to the sort of diversity of actors that are involved. You know, the people who are, so to speak, turning off the tap in Yunnan are definitely not the same people who are, you know, building a hydropower plant you know, 1,000 miles away. So, you know, it's a really interesting question, one that I hope somebody answers, about, you know, sort of coordination on hydropower strategy. And yeah, I don't really, you know the answer yet, but definitely will hope to explore that, especially in a case study approach. And so, yeah, another sort of related concern that comes with that is also that it's really hard to isolate the environmental impacts of a single hydropower plant when it's on a connected river system. You know, the more dams you put on a river, you know, that could have cumulative impacts. And I'll confess that, you know, being sort of unfamiliar with the mechanics of that is not something I fully understand. And I do hope to work with somebody who understands that a lot more, because, you know, it's quite different from my previous work on coal plants, where you could sort of assume some amount of discreteness in terms of the environmental impacts to some extent. Whereas hydropower, definitely not the same. So that, you know, in your question, you said it would be important to include the Chinese hydropower within China in the assessment of environmental impacts, again, because it is upstream, it is connected. So yeah, that's something that I'm still thinking about how to handle, and may to some extent determine what environmental metrics that we look at may even also affect the discussion about social metrics. And then I think your final question on uncertainty and merging data, I just wanted to see if Dinah had any comments about that.
Yeah, so the question on how do we assess the likelihood that two observations that didn't merge cleanly actually represent one underlying plant? That's certainly the goal of the merging algorithm in that Ruby script. I would say that one is looking at those outliers. So when we showed the density plot of the capacity values, there were a couple of outliers where the capacity differed by 500 megawatts, even 1,000 megawatts. That's a pretty solid sign that something that went wrong there, whether that was the merging of two plants that shouldn't have been merged, or that one of those sources has inaccurate data. So that's kind of the flip side of the question that you're asking. When we want to look at two observations that should actually be one, that's a little bit more difficult. There are a lot of pieces of metadata that we can use to try to find those, namely capacity. We can also start to look at geocoordinates. But geocoordinates do also differ a little bit between sources, so we would need to add a little bit of tolerance for error. I guess the limiting factor there is really just what attributes do we get from all sources. Because geocoordinates aren't available from all sources, it means that we can really only use that to try to find joins between two of the three data sources, or two of the eventual four data sources once we add WRI in. So those are some of the things that we can try in the future. And it's certainly something that we can continue to improve as we come up with new ways to identify those matches. We can kind of add onto the script and rerun and know that we'll have a fairly deterministic behavior.
And then to Yan Wang's question, let me share my screen again. So I had this slide, can you guys see it? Of the electricity by generation by source, because the question was about, you know, what are the country's existing and alternative power sources, and are hydropower stations addressing the bottlenecks, the energy bottlenecks in the country. And so, yeah, apologies, this is kind of small, but the blue represents hydropower, orange is gas, and gray is coal. So you can see this is the actual generation by source in the 5 Greater Mekong subregion countries, excluding China. And I think that if you looked at installed capacity, it might be a slightly different picture, which is why I chose to look at generation. You know, how are they actually meeting their energy demand? And I think that if you look at IEA scenarios, you know, they project electricity demand out several decades, you can see, I didn't put it here, and I should hopefully in a final product, about projected electricity demand that will certainly be affected by what's happening now with COVID and sort of changing projections. But as I mentioned, each country will be meeting that future demand with different sources of energy. I think in some countries, there's just not that much more potential for hydropower. It's essentially already been fully exploited, whereas in others, there's a lot more room for additional hydropower. And similarly, the really interesting thing about this region is that coal is still a very cheap and plentiful source for electricity. And so the question is, going forward, balancing the sort of climate impacts of an energy source like coal with the local environmental impacts of a source like hydropower, where does that leave renewable energy like wind and solar, which are quickly coming down in cost, and a lot of these countries do have significant potential for wind and solar, but how are they going to compete with coal and hydro, which have so much investment and support, for example, from Chinese actors, as well as domestic institutions. And that sort of brings me to a lot of the other research that I'm doing, which is really about what host countries are doing, given the different needs for their domestic energy systems, and with China coming into play, what's going to happen. So thanks for your question, Yan Wang. That definitely is something that I'm thinking about in most of my projects these days. So I look forward to continuing the conversation.
Well, thanks a lot, Cecilia. Thanks a lot, Dinah. Great presentation, and we look forward to seeing how this work develops, and hope some of the comments and questions that you got from folks out in the audience have been helpful in you folks moving forward. I want to thank everyone for coming, and before I let you go, I just want to remind you about some more seminars in this series and some other things going on at the GDP Center. The best way to track what we're doing is to go to our webpage and look at our events page, and also sign up via email to get alerts from us on a whole bunch of these things. The next Global China Research Colloquium is next week at 9 a.m. EDT, and we'll be featuring Dr. Barbara Stallings from Brown University, and she'll be presenting her new book, Dependency in the 21st Century, The Political Economy of China-Latin America Relations. We're very excited to have her come with us. The GDP Center has two other big research clusters here at the center. Another one is called the Human Capital Initiative, and those folks also have a seminar series that started last week. And the next one in that series will be October 28th. Those are at 3 p.m. EDT, so a little bit harder for folks in Asia. And that one is called Creative Construction: How Bureaucrats Build and Stop Infrastructure in Latin America. Our other research cluster here at the GDP Center is called the Global Economic Governance Initiative, and we have a seminar series for that this semester. The first one in that seminar series is next Thursday, October 15th at 9 a.m. EDT, and that'll be a conversation between myself and the Nobel Prize winner Joseph Stiglitz, discussing the IMF, the International Monetary Fund's performance in the COVID era for developing countries. So as always, we invite you to all of these. Really hope you can come and be engaged, and please take a look at our website to find where you can find some of this research, some of these interactive databases, and engage with us with our different seminars. This is where we usually have a round of applause for our two speakers and invite you to have some cookies and coffee. Unfortunately, we'll have to take a rain check on that one, but thanks a lot again, Dinah and Cecilia. Have a great day, everybody, and thanks for coming.
Thank you.